Hello YouTubers, and welcome back to another episode of Zerks&Wheels. Today in this episode of Pipe Flange Welding 101, show you a basic setup on how to get a pipe flange set up on a pipe. This is for people who are interested in using pipe flanges, or maybe even start doing some welding in this department or in this field. Now, I'm not a pipe fitter, so there may be a mistake or two that creeps in here. So any of you that do have any experience, by all means, chime in the comment section below and point out the mistakes I'm making, or anything that any discrepancies you might see and appropriate corrections that need to be made. Well, anyway, let me zoom you in here on what I'm doing. Just making a short little connector piece here, adapter for a steam pipe, or actually a condensate pipe or a manifold. So show you here what I'm doing. Okay, what I've done here is put my copper plate into the vise, and on the straight edge I lined up the edges, the inside edges of these two holes. Normally for 8-hole flanges, these two holes would be lined up on a straight edge or on a level. But this particular application requires 4 holes, so we're going to need these 4 holes and these 4 holes. And so what I've done is I've lined up these 2 holes on the straight edge of the pipe here, and or on the of the copper plates. And now as I look through and I stick in put some pressure on here, my flange is lined up perfectly on these on the edge, and now we've got a nice line going across this one. Now, this is where eyeball comes into play here. So now I've got my straight edge up here. Again, get this lined up nice and, whoops, slip there. So now we've got to take a step back and eyeball this to this edge right here on the copper plate. So let me step back here and take a peek-see. And I just turned it just ever so slightly. So now we're all lined up. Now we're ready to tack. Now the wire, I placed a wire in here. This is for a precision piece, so it had to be fairly square. Had to turn this edge of the pipe on the lathe to get it nice and square to the pipe. And normally, just cutting it on a saw would be good enough. Then you'd use your pipe flange square. This piece here is too short to demonstrate the pipe flange square today, so I'll save that for another time. But anyway, got to put some gaposis in here in order to get some penetration. And so I took a piece of 1.5mm wire, just folded it into a U and stuck it in here. So now my first tack is going to be right here. Then I can open this up, pull the wire out to where this wire is over here, and let the other hang out, and then I can tack either side of it. And I got 3 points, and the part won't move too much. So let me go ahead and do that. And okay, now we've got our tack. Now I can remove this. Lift up just a smidge so that the wire will come out, because you do get some shrinkage of the weld when this cools off. So now we're going to give it a tack right here. now what we're going to use is just the very tip of this wire in the cut. Don't really even need it for that matter. I'm just going to leave it out. So now we're going to leave out the wire completely and give it another tack over here. So now we're ready to give it a weld all the way around. And one thing I wanted to show you guys before I get to welding on this is this old parting head here. I actually bought this thing as a parting head, but somebody got to welding on it. I bought it for the chuck actually, mostly more than anything. But being how I can't get the chuck off of this thing now without doing damage to it, I figured, well, I'll use it for this purpose here. So for welding, this thing has been really handy as far as that goes. It acts like a rotary head for, you know, a rotary welding table. So now I'm just going to keep it on here and then just roll it slowly as I go around and advance on the weld. So the first additional thing I'm going to do is give it a few more tacks so that this thing can't move too much. Now I got a good ring of tacks, about 6 all the way around. So now we're just going to fill in the gaps. Now what I'm also doing is I'm focusing most of my heat on the flange because that's got the largest mass. That's where most of the heat's going to be absorbed, and so now I'm going to make sure I get the best penetration on this side because the pipe over here is thinner than the flange, and so it won't be hard to get the penetration you need on the pipe, and that's why you concentrate more on the flange, on the heavier mass. Now, since this is going to be a low pressure application, I don't really need to put a double pass or a cover pass on this. I'm just going with a good filler pass slash root pass to get this penetration that I need on both sides, and then call it good, because like I say, there's no pressure on this thing. It's a vacuum side, so if anything happens, it'll just suck a little air and that'll be the end of it. So let me bring you back after I'm done here with all this and continue on. Now looking into the pipe here, we can see we got some fairly good penetration. It's not all the way through. I used a fairly thick filler rod in order to get a single pass weld on this. Here's some failure analysis of an old elbow. This isn't a very old pipe, but you can see there's a row of letters along the crest of the pipe, and it developed a little pinhole So I tried welding that, and as you can see, it was so thin it just burned right through, and that was with 50 amps. And there it is from the inside. Now around here you can see another, whoops, get back here. You can see another hole right there developing. That would have been the next pinhole. And as you can see, the weld had fairly good penetration all the way around. Right here is where the wall is a little thin, but not too bad. There was a good cover weld on the cover bead on here, so this wouldn't have ate through in anytime soon. Now, in order to get good penetration on a flange like this, what you would want to do is, this is a no pressure application, so I used a 1.5 millimeter rod. If this were a pressurized application of, say, up to, well, let's say 50 psi, I would have, or even higher, I would have used a 1 millimeter filler rod and gotten better penetration in order to fill in the gap between the flange and the pipe, and actually bumped up the amperage. I'm running 75 amps on this weld, and I would bump it up to about 85 normally in order to get better penetration on the flange, and then also allow a better melt and material flow between the pipe and the flange, and actually allow some of the weld not to completely fall through, but penetrate enough to where it's sticking out into the cross section of the pipe. And now, one of the things you got to keep in mind is that steam is a fairly aggressive medium, and it will eat into metal fairly quickly. And with welding this stuff, especially on a TIG, you're not getting the argon shield on this side of the pipe, so you're going to be changing the oxidation state of the pipe on the inside and the flange on the inside, which means it's going to be more susceptible to oxidation from the medium traveling through the pipe later on. So that's why you want to get good penetration in a pressurized application. And so I would have been using, in order to get that done, I would have used a 1 millimeter rod, filler rod, and like I said, 85 amps. This I was running at 75 with 1.5 millimeters, so that way I only have one pass on the filler, and got a fairly good penetration. For this purpose, it's good enough. So keep that in mind. And we saw the failure analysis here of this elbow. So don't know what else to add to it. If any of you out there watching this stuff have any experience on this and would like to add to the conversations, by all means do. Anything you have to say is certainly welcome. You know, this is a channel for education and showing folks how to get stuff done and explain the processes and some of the science behind it. So anyway, I do thank everybody for stopping by and watching today, and thank the new subscribers that have came on board that are interested in this theme. So any comments and thoughts are always welcome. So we'll hope to see you guys soon.